Hello, welcome to Maths with EJD. In this video, I'll be talking about the Python code for sensitivity analysis of a portfolio optimization problem. So it's the same portfolio optimization problem I considered in the previous video, where we looked at different scenarios after getting the optimal solution to the problem currently displayed on the screen, where we are tasked to carry out sensitivity analysis on the optimal allocation of investment in three different assets to maximize the expected portfolio return given specific constraints. So you have the objective function there, which is z equals 0.12 W1, 0.10 W2, and 0.08 W3, all of that added together. So W1, W2, and W3 are the proportion of portfolio allocated to assets 1, 2, and 3 respectively. And as you can see, right, the expected returns for assets 1, 2, and 3 are 12%, 10%, and 8% respectively. Then you have the constraints, right? W1 plus W2 is less than or equal to 0.8. Talking about total investment in assets 1 and 2, which cannot exceed 80% of the portfolio. Same for total investment in assets 1 and 3, which cannot exceed 80% portfolio. That's W1 plus W3 is less than or equal to 0.8. Then, of course, the sum of all investment must equal the entire portfolio, which is 100% of funds. So you have W1 plus W2 plus W3 equals 1. That's the sum of all the proportions will add up to 1, right? Talking about the whole investment. And there's a non-negativity constraint, which in practical terms would mean no short selling is allowed, right? No negativity. Okay. So that's why W1, W2, W3 are all greater than or equal to 0. And of course, since the focus is on sensitivity analysis, right? There's no, it's always cool. Now, normally, right, if you have this problem, you're expected to first of all solve it using simplex method, get the optimal solution, and then you now begin to consider different scenarios for the sensitivity. So here we've been given the solution up front. The optimal allocation of weights is found to be W1 is 0.6, W2 is 0.2, W3 is 0.2, meaning the proportion of funds that should go for first asset is 60%, second and third assets will be 20%, respectively, adding up to 100. And the optimal portfolio return. So with this allocation up here now, the maximum portfolio return Z is actually 0.1080, which is 10.8%. So of all the investments made, 10, so there is 10.8% returns. Okay. So this is the code right here. Okay, let me put line numbers for easy referencing. Yeah, so here we're just using limprog and NumPy. So you have the C base, right? The normal C, which is 0 minus 0.12 minus 0.10 minus 0.08. And then you have the coefficients, right? Uh, for W1 plus W2 is less than or equal to 0.8. That's W1, W2. W3 is not there, so that's 0. So that's why you have 110. Then W1, W3. So that means W2 is 0. That's why this is 101. And talking about the right-hand side, right? You have 0.8, 0.8. That's what you have there. Then for the equality constraint, right, you have A underscore EQ, line 9. So that's why that is 111. And the right hand side of the equality constraint is also 1. Then the bounds, I mean, non-negativity constraint, everything is greater than or equal to 0. So to solve this now, so you have results, limprog, C base, talking about the C side, you have the A, you have the B, you have the equality constraint for equality, you have BEQ also. That's the right-hand side of the equality constraint. You have the bounds, and we are using highs to solve this. We could as well just change it to, okay, well, after solving with highs, I'll come back later and also do simplex. It will definitely give us the same results. So line 19 to, I mean, 19 to say 26 is actually a condition. We want to output the optimal solution if found, in case the optimal solution exists. So we want to get W1, W2, W3, and the maximum value of Z. So, and of course, we are put that Z there is minus result is actually negative because we minimize the negative objective function. So if you have a maximization problem, you negate it so that you can solve. So by the time you're outputting the result, it will be negative, so you can multiply by minus and you get your result back. So if there's no solution found, it to be indicated as shown in line 26. And then in line, so up to line 26, right, we would have got the optimal solution. Then from line 28 now, what we are now doing are the sensitivities. So we now have defined sensitivity analysis objective. So we have the C base, we have A, B, and all those things. And then we have the percentages. So we have -5, that's -5 decrease, 5% decrease in whatever we set we want it to decrease, like percentage change to apply to the coefficient. So, sensitivity analysis usually would apply to objective function coefficients or constraint limits, right? So -5 means we are reducing the objective function coefficient by 5%. +5 would mean we are increasing by 5%, just like what I did when we're doing that manually. Then we have all the whole percentages thing going on around here. And then that will end up returning the result for W1, W2, W3 for this minus and plus thing that we've done here. Then so line 53 is us calling out the results. So call the objective the function to check to check sensitivity of the objective coefficients now. So this will help us get the results. So output the sensitivity analysis results. So the results will be outputted from lines 56, I believe, to line 66. Then from line 68, that's where we are talking about sensitivity analysis for the constraints right-hand side. That's the constraint limits now. So we define that kind of function we defined before for the objective function, right? We define all of that. And then, we also end up calling the results. And by the time you just click on this, in one blow, you get all the results. So the first one is the optimal solution when you solve normally. So you see 60, 20, 20, that's 0.6, 0.2, 0.2, and the maximum return is 0.108, that's 10.8%. Now, sensitivity analysis for objective function coefficient. So imagine percentage change is -5%. That is when you reduce the coefficient by 5%, then you get, so you see the value W1, W2, W3 remains the same. So even when you increase, it also remains the same, except that there'll be slight decrease for -5%, and there's slight increase for +5%, just like what we got in the previous video. Then if you now talk about sensitivity analysis or the constraint limits now. So if you increase the constraint limit by 5% or decrease by 5%, -5 is decrease, -5 is increase. So you see that it affects the optimal solution. So for when you decrease by 5%, the W1 is now 0.52, W2 is 0.24, W3 is 0.24. So that's like 52% for W1, 24% for W2, and 24% for W3. And then the maximum Z is slightly reduced from 10.8% to 10.56%. And then if you increase the constraint limits by 5%, that was what we were getting. Instead of 0.8, we were getting 0.84. The reduction was the 0.76 thing we had in the previous video. And then here, you also have so you see a lot. So because of the increase in the right-hand side, right, there's a shift to more investment in the first asset with W1 now 0.68, which is 68%, and W2 and W3 has 16% apiece. That's 16% each. And then the maximum return is now 11.04% compared to the original 10.8%. And that's how that has been. So you can always play with this to actually understand this better. All right, so if you have not subscribed to this channel, be sure to do that and hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know if you want me to teach a topic or solve a problem, like and share so that more people can have access to this great learning. Till I come your way again, keep optimizing. Bye.